Hello everyone, this is Magongo Bright, your new grade 12 NSC Math and Physics tutor. Please follow the link, click the subscribe button and hit the notification bell so that you'll be notified on all the videos that will be posted on this new channel. Today I would like us to look at mathematics. As you are still about to write Math Paper 2 on Monday, we'll be having a revision on trigonometry, as it is the second section with a lot of marks on paper 2. Stay tuned. Don't forget to like and comment. Today I'd like us to start with 2017 paper supplements question 5. Let's look at the questions. Given that sin A is equal to 2p and cos A is equal to p, determine the value of tan A. Okay. We all know that from the trigonometric ratio, sin A is equal to the opposite over hypotenuse, and cos A will be equal to the adjacent over hypotenuse. Therefore, tan A will be equal to opposite over adjacent. They say determine the value of tan A. If you can look at this concept, if I can divide sin A with cos A, using the trigonometric ratio, sin A is equal to opposite over hypo, all over cos A is equal to adjacent all over hypo, equal to. When I divide, a number is the same as when I multiply with its reciprocal. So it will be opposite over hypotenuse times hypotenuse over adjacent. This will be y times r over r times y, where r will cancel each other and it will be y over x. And if you can look properly, this is a trigonometric ratio for tan. That means when you have tan A, it is also equal to sin A over cos A, which is the quotient identity, and we'll learn about it in grade 11. Looking at the question, determine the value of tan A. Tan A must be equal to sin A over cos A. You are given that sin A is equal to 2p. You are given that. All over cos A is equal to p. Then the p will cancel each other. Therefore, tan A is equal to 2. I hope you understand the first question. Okay, let's look at 5.1.2. Without using a calculator, determine the value of p if A is an element of 180 to 280. Basically, to attempt this question, you are given that sin A is equal to 2p and cos A is equal to p. It is wise that you must draw some sketch diagram. Sin A is equal to p, and this is all over 1. We all know that sin is opposite over hypo, which means our opposite is 2p and our hypotenuse is 1. Our angle is A. The opposite side is the side that is opposite to the angle, and it is 2p, and our hypotenuse is 1. Then we go and look for the adjacent side using a Pythagoras theorem. It says x squared plus y, you have 2p all squared is equal to 1 all squared. X squared plus 4p squared is equal to 1. X squared is equal to 1 minus 4p squared. When I take this to the other side, it changes its sign. And when I take the square root of x is equal to plus or minus the square root of 1 minus 4p squared. Therefore, since x is positive, x must be equal to positive square root of 1 minus 4p squared. On the other side, you also have to do its sketch diagram, and the angle is A, all over 1. This is adjacent over hypo. Since our adjacent side is the side between the angle and the 90 degrees, therefore this is P, and this is the hypotenuse side, which is 1. You go to look for the opposite side. Using a Pythagoras theorem, x squared plus y squared is equal to r squared. Our adjacent side is P, all squared, plus our opposite side is equal to 1 all squared. P squared plus y squared is equal to 1. Y squared is equal to 1 minus p squared. When I take p squared to the other side, it changes its sign. Then I take the square root of y. Y will be equal to plus or minus the square root of 1 minus p all squared. Since y is positive, y will be equal to plus the square root of 1 minus p squared. Therefore, it is the square root of 1 minus p squared. Then, most of the time, you have to use these two diagrams in order to find all the answers that you're looking for. If you can look, the question says determine the value of p. It wants the value of p. If you can take any trigonometric ratio here, let's say you take sine p to take sine A. Sine A you are given that it is equal to 2p. And sine A is opposite over hypotenuse, which is equal to 2p. Our opposite side is 2p all over our hypotenuse side is 1 equal to 2p. It will end up 2p is equal to 2p. Therefore, the p will cancel each other. That means this two sketch diagram won't help us. If this two sketch diagram doesn't help us, I have to go for the basic of trigonometry. What are the basic of trigonometry? Is the quotient identity and the square identity. The quotient identity is tan A must be equal to sine A all over cos A. Yet the square identity is sine squared A plus cos squared A is equal to 1. If I use this quotient identity, you all know that tan A from question 1, we are given that it is 2 equal to sine A, we are given that is 2p all over cos A, it is p. Still, the p will cancel each other. Therefore, we won't find the value of p. Let's go for the third option. Let's use the square identity. If I use the square identity, it says that sine squared A plus cos squared A is equal to 1. Sine A, we're given that is 2p all squared plus cos A is p all squared is equal to 1. We're given that sine A is 2p all squared plus we're also given that cos A is p all squared is equal to 1. If I solve this thing, it will be 4p squared plus p squared is equal to 1. And these are the like term. 4p squared plus p squared is equal to 5p squared equal to 1. Then I divide by 5. I divide by 5. P squared is equal to 1 over 5. Then I take the square root of p, because they want the value of p, not the value of p squared. I take the square root of p squared. P squared will be equal to plus or minus. The square root of 1 is 1 all over the square root of 5, it's root 5. Since I am restricted, that means p, not p squared, sorry. That means p, not p squared, is equal to plus or minus 1 over the square root of 5. Okay. From this restricting, we are restricted that A must be in elements of 180 to 270. Okay. This is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. On this quadrant, we have 90, 180, 270, and 360. Okay. It say it must be in element of 180 into 270. So A must be in this quadrant 3. Okay. If you can look, P, we say P is plus or minus negative, is plus or minus 1 over root 5. Okay. Since we are looking at this quadrant, to find P, on the third quadrant, okay, on the first quadrant, all the trigonometric ratios are positive: sine, cos, and tan. From the second quadrant, only sine is positive. Third quadrant, only tan is positive. Yet on the fourth quadrant, only cos is positive. To obtain these values of P, we have used sine and cos. Both sine and cos are negative on the third quadrant. That means the value of P must be negative. Negative 1 over root 5. That is the answer. Why I choose negative? It is because both sine and cos trigonometric ratio are negative on the third quadrant. Okay, let's go for 5.2. It says determine the general solution of 2 sine squared x minus 5 sine x plus 2 is equal to 0. To make it short, let's just say let sine x equal to k. It's a simple method. Then it will be 2k since it's squared minus 5k plus 2 is equal to 0. Okay. You can solve this in different ways. Some other people you can multiply the a value with the c value. Some can just solve it as it is. It will be 2k, it will be k. So that's when you multiply k times 2k, it gives us 2 squared. Then the factors of 2 is only 1 and 2. But if I multiply the outer bracket and multiply the inner bracket, then I add it, it must give me the middle term. How? It will be 2 and 1. When I multiply these numbers, must give me positive 2. So that means they must be all negative. If I multiply the outer bracket, it's negative 4. Then I multiply the inner bracket, it's negative 1. And I add it, it gives me negative 5. That means 2k minus 1 is equal to 0. Or k minus 2 is equal to 0. And these are the critical values. 2k is equal to 1. Or k is equal to 2. 2k is equal to 1 over 2 if I divide with 2. We know that k is equal to sine. Therefore, sine a or sine x is equal to 1 over 2. Or sine x is equal to 2. And this one has no solution. It is unapplicable. Okay. Sine x is equal to 1 over 2. Then you shift this one. It will be x is equal to 30 degrees, which is our ref angle. This is not the actual answer. Then you have to look for sine, where sine is positive. Since it says sine x is equal to positive 1 over 2. Sine is positive on the first quadrant, and sine is positive on the second quadrant. That means the actual answer is x is equal to 30 degrees plus k dot or 360 degrees, which is the period of the graph. Period of the graph. Dot OK is an element of integer. X is equal to 30 plus k dot or 360, and OK is an element of integers or of integers. This is the first quadrant. Then you have to look for the second quadrant. The second quadrant is 180 minus. That means x will be equal to 180 degrees minus the ref angle, which is 30 degrees, plus k dot 360, which is the period of the graph, dot OK is an element of integers. X will be equal to 150 degrees plus k dot 360 dot OK is an element of integers. And that is our two answers. Okay, let's look at question 5.4. Prove the identity. Trigonometry is a sort of algebra. We have to prove that tan x plus 1 all over sine x times tan x plus cos x is equal to sine x plus cos x. You have to take one side at a time, and I take the left hand side. Tan x is the same as sine x over cos x plus 1 from the quotient identity in grade 11, all over sine x dot or sine x over cos x plus cos x. Okay, let me solve this thing first, or take the LCM of this thing. LCD, it will be cos x, then I cross multiply. It's sine x plus cos x, all divided by sine x times sine x is sine squared x all over cos x plus cos x over 1. This will be sine x plus cos x all over cos x, all divided by LCD, it's cos x all over, I cross multiply, it's sine squared x plus cos squared x, since cos x times cos x is cos squared x. This will be sine x plus cos x all over cos x times, when I divide a factor or a number, is the same as multiplying it with its reciprocal, times cos x all over sine squared x plus cos squared x. Sine squared x plus cos squared x is 1. That means sine x plus cos x times cos x all over cos x, since this one is 1. And cos x will cancel cos x. Therefore, it will be sine x plus cos x. Therefore, the left hand side is equal to the right hand side. And here is the hint. You don't have to equate these things since you are proving it. 5.5. Consider sine x plus cos x is equal to the square root of 1 plus p plus k plus k. Determine k as a single trigonometric ratio. We are given that sine x plus cos x is equal to the square root of 1 plus k. You have to express k as a single trigonometric ratio. That means you have to leave k as a subject of the formula, and it must be equal to the equal to a single trigonometric ratio. First of all, I have to square both sides. If I square both sides, the square root of this, if I square both sides, sine squared will be sine all squared will be sine squared x plus cos x times sine x times 2 will be 2 sine x dot or cos x plus cos x all squared is cos squared x equal to, this squared will cancel the square root, 1 plus k. Okay, this is the same as sine squared x plus cos squared x plus 2 sine x dot or cos x is a double angle of sine, which is sine 2x is equal to 1 plus k. Sine squared x plus cos squared x is 1 plus sine 2x is equal to 1 plus k. I have to leave k as a single, I have to leave k equal to a single trigonometric ratio. I take this one to the other side. It will end up being k is equal to sine 2x plus 1 minus 1. If I take 1 to the other side, it changes its sign. Therefore, k must be equal to sine 2x. Okay, let us look at question, this is question 5.5.2. Remember, from the 2017 supplement. Hence, determine the maximum value of sine x plus cos x. We're given that sine x plus cos x is equal to the square root of 1 plus k. And with the word hence, it said that I must use the previous answer. Okay, that means from the previous answer I got that k is equal to sine 2x, which means I must use the answer, or I must use the previous answer to find the maximum value of sine x plus cos x. Okay, that means sine x plus cos x will be equal to the square root of 1 plus, since k is equal to sine 2k, it will be square root of 1 plus sine 2x. Therefore, sine x plus cos x is equal to 1 square root of 1 plus sine 2x. The maximum value of sine 2x plus 1 is 2. Okay, that means since the maximum value of sine 2x plus 1 is 2, then the maximum value of sine x plus cos x is equal to root 2.